Hi, this is Ross from VSM. In this video we're going to take a look at the AES dashboard. We've got a situation here where we can show you an AES with lots of stuff wrong and shows you how the dashboard behaves in those examples. All of the VSM dashboards follow the same sort of format where we start at the hardware layer and work our way up through the layers of hardware, software and the application layer in various elements of configuration and capacity. The idea behind these dashboards is that they reduce your mean time to repair, maximise availability, and they do that by taking a bunch of commands, the sorts of commands that an experienced Tier 3 engineer would use to troubleshoot and ascertain application health and server health, and we run those on a regular basis. So minute to minute we're running all of those commands and we're dashboarding the results. And the result for the VSM user as a consumer of those dashboards is that they can see at a glance anything that's going wrong. If there are workflows configured, they'll be notified about the issues proactively, so you don't have to sit there and watch a dashboard. But the idea is that we pick up the stuff that's usually quite hard to find, that's causing issues at an application layer, particularly further up the stack, the sort of stuff that will never generate a trap. So if you're just listening for traps, you'll never know about this stuff. And the idea is to get onto that sort of thing, that sort of impending problem before it actually causes a business outage. So we start at the top with this particular example. This is a lab AES here where VSM is based. Up the top here we have the hardware. So this is super hardware, the actual box itself. How's it performing? A few aspects of its configuration and so forth. So it's configured as AES2 up here, that's the host name. The uptime over the side here has been running for 44 days roughly. And the reason we track this is some IT departments have a policy of rebooting servers every 30 days, every 90 days or so forth. And this way we can track the uptime. So time since the last reboot. Through the middle portion here is the occupancy of the server itself, so processor memory disk utilization. You can see here there's a couple of major issues happening with this processor at the moment. It's sitting on 100% occupancy and it's consuming 99% of its allocated memory. If we expand the occupancy dashlet there, we can see how the occupancy has been tracking over the last 10 minutes. So the processor has dropped away from that 100% level briefly, dropped down to more regular levels around 9-10%. But there's definitely something going wrong there from a loading perspective with this box. That's why we've got these traffic loaded in the red status. So moving up away from the hardware layer to the software. So through here on an AES we've got 6 crucial software services that need to run. ASDI, TSDI, DLG, CVLAN, DMCC and transport. So what we're doing here is every minute we're pinging these software services that add an application layer to make sure that they are running. So if they are responding properly, if they're responsive, we'll green light them, we'll call them online. If they don't respond, we're traffic lighting that. And in this case the DLG and the CVLAN are orange. They're not responding, those 2 software services, and in fact the reason they're not responding in this case is they're not licensed. So they're sitting there orange. So I just collapse that again and expand the next layer. Next layer, in fact these next 2 layers we put in based on feedback from the base, so thanks to those that have contacted us and asked for this feature because it seems to be pretty well received. And this is where we're tracking the DMCC licenses. So this is one of the main reasons that call recording stops, is that the DMCC license is oversubscribed. So in fact there's 1,490 licenses here. Where you get into a situation where 1,490 are required and then perhaps the call recording application needs another license to do another recording, can't acquire it, that call recording is missed. It's one of those examples where there is never a trap generated for that, so you don't know about it. If you're just monitoring traps, you're completely in the dark. All you tend to get in that situation is you get one of the contact centre supervisors coming to you saying, we've had a major dispute with a customer, there's, a lot of money at stake, we need to recover the call recording because there's a dispute between us and that customer, and you try and find the recording and it's not there, and it's a bit of a mystery as to why that call wasn't recorded. Murphy's Law, it always seems to be the call, of the high value, the one you really need is the one you can't find. And what we're doing there is notifying you if there's going to be an issue around that licensing side. Very similar approach with the TSAPI. So in this case we've got a couple of different TSAPI licenses. We've got the TSAPI user license and we've got the unified desktop license. So there's the total that have been purchased on the right hand side, and then the numbers that have been acquired by various applications for use. So very similar to the DMCC license, we'll tell you if these are expiring. Next layer down, you've got the switch link layer. So this is the links that are configured to talk to the switch through the communication manager, and we are statusing those links, and you can see of the 5 that are configured here, in fact 4 of them are down. So this is a lab environment, so we are expecting to be issues like this. But again, you don't get traps for this sort of thing. You don't get notified. There's no trap generated by Communication Manager. There is no trap generated by the AES out of the box. So this is something that needs to be monitored at that application layer. Next layer up, and another area that's responsible for causing issues is the TSDI buffer. So there's a buffer allocated within the AES. That buffer can overflow. So you can see here we've got the buffer size and we've got the amount that's allocated. So currently that's all green. We're not actually drawing down on those buffers at all. But when you do get those TSDI buffers overflowing, that's when you get some really weird things happening, like your telephony state is out of sync with your application state. So your application may think that there's an agent on a call, but in fact the agent's not on a call if you look at their telephony state or their hard phone or their soft phone. Those sorts of weird things happen when this TSDI buffer overflows. Collapsing that, and then the final layer through here, the ACM to AES connection state. So this dashboard actually logs into both the AES and the Communication Manager, and it looks to see how these guys are configured and talking. So it's self-detecting, self-configuring, and in fact if you change the way that this is working, the dashboard in itself within a minute will change and reconfigure itself to monitor the right things. So the reason we're monitoring these is that there are capacity issues around this specified by Avaya, and those capacities are the transmit and receive messages per second on each link. So in this case the AES is configured as server 2, it's using CTI link 12 within Communication Manager. Both ends of that are up, and the message rate between the two looks like they're using CLAN boards on link 2 and link 3. The message rate here is well within Avaya specifications. So Avaya do specify how fast this message rate can go on these 2 links, and they also specify the total, the combined total. So we are dashboarding those, we are traffic lighting those, and if you exceed the message rate that's running between Communication Manager and the AES, we'll let you know about that proactively. And that's another area where it's pretty much invisible to most people. You start getting weird things happening with the AES. The switch links are up, everything looks good. There's no alarms being thrown. Error logs, event logs look clean, and all you're simply doing here is overdriving this message rate, because these CLAN boards that are in behind here, they'll run as fast as they can. There is no throttling done on them. There is no obvious signs of any issue when that rate starts to go up too high. So hopefully you can see there what we've captured. We're capturing all that stuff right through from the hardware layer, right through software, licensing, and the application state, and the links, and all of the capacities that apply to those guys. So an awful lot of intellectual property embedded inside that dashboard, and it will maximise your availability. It will reduce your mean time to repair, simply because you've kind of got a software-based Tier 3 engineer running these commands, looking at your platform for you on a continuous basis. So hopefully you'll find this this dashboard really useful in your environment and maximise your uptime as a result. As per usual, any ideas, any suggestions for improvement, please let us know. Drop us an email at support@vsi.com, and if we like what you're suggesting and we feel there's broad appeal, we'll code that in and we'll bring that into production, and all VSM users globally will benefit from those suggestions. So please keep them coming. Cheers.